Whenever someone pitches me an idea, there's always a quick test I like to run. If you got everything that you say you want, does it achieve the outcome you desire? This is the greatest test of efficacy. Now, what problem are we trying to solve here? Climate change, right? What causes climate change? Heat. What causes heat? Is it the addition of greenhouse gases to the atmosphere? No. It's the carbon dioxide and the other greenhouse gases that we already have in the atmosphere. So here's your first gut check on any solution towards climate change. What does it do about the 1,000 gigatons of extra CO2 that we already have in the air? Tell me, what's the most ambitious plan that you've ever heard? Decarbonize the entire electricity grid in the US at some point in the second half of the century? Is it decarbonize the entire US economy at some point? How about this? How about net zero global emissions across every sector? Electricity, transportation, agriculture, industry, heat. Ambitious, right? But would even that solve our climate change problem? Not even close. If we shut down all the fossil plants across all the world tomorrow, if we had 0 people on the planet tomorrow, we would still be doing just as much damage to the climate from the heat that we've already added to the air. About 2 watts per square meter of radiative forcing. That's if we got rid of all fossil fuels tomorrow. Now, when I started the Energy Impact Center, which hosts the Titans of Nuclear podcast, I was just trying to properly define a problem. And now I learned that the consequences of climate change are going to be way worse than I previously thought. But the more that I learned about energy itself, the more optimistic I became. I'm optimistic because while it seems like there is no solution, I realized that the problem itself was universally being framed incorrectly. Okay, so let's just reframe it and work backwards. What's the problem? Stop climate change, right? Well, first we should actually ask ourselves why. Can't tell you how many times people bring ideas forth and they think it's such a good idea. They're so compelled, but they don't have a good answer to the simple question is why you're doing it. All right? Because you have to run that by your outcomes as well. So my answer to that is to limit environmental damage and human suffering. All right? So more specifically, our problem statement. Stop climate change in order to limit environmental damage and human suffering. But that means we have some constraints too, right? Problem, we got some constraints. So let's establish a few. The first one, our solution must not induce rapid changes to precipitation patterns. To many of the poorest people on the planet, this would accelerate the worst possible outcome. We have over 2 billion people that do not have the agricultural know-how, the infrastructure, or the capital to adapt to any sudden changes that may occur. And they would be forced to abandon their home after just a few years of abnormal rainfall. So unfortunately, this pretty much rules out the quick and cheap geoengineering fix of reflecting sunlight that you hear about sometimes. Even if it would have a long-term positive effect on crop growth, regional changes to expected water, too little or too much, can instantly send millions into starvation and relocation, or worse, as we've seen in Syria and Central America, dire civil conflict. Let me drive this home. If we mess with precipitation patterns on a global scale, the second-order effects of food and water security could simultaneously destroy the lives of millions of times more people than any wildfire, flood, or hurricane could. That's constraint number one. Constraint number two. Our solution must align short-term individual interests with global long-term interests. We have billions of people on this planet for whom the limiting factor to prosperity or even basic well-being is access to energy. Energy is everything. Energy is building materials. Energy is medicine. Energy is the ability to communicate, to transport goods and services. Energy is access to opportunity. So no matter how you see the situation through a resource-rich lens, there is no universe in which the resource poor will voluntarily elect to sacrifice energy. I'm not even sure most of the resource-rich would make that choice themselves. Not only does this constraint apply to individuals, it applies to countries as well, which is why there has never been an international agreement with any semblance of enforcement. This constraint also implies that we actually need more energy than ever, and it has to be cheaper than ever before, so no one is forced to sacrifice. The corollary of such is that producing the energy itself has to fix the problem. Otherwise, there would be an inherent capital sacrifice. Constraint number three. We need to both replace all fossil fuels in every single sector globally and remove carbon way faster than we ever put it into the air to begin with. Remember, like I started off with, it's the addition of heat that is causing temperature rise, not the addition of carbon dioxide. So given the last 200 years of CO2 accumulation, the climate is 2 orders of magnitude more sensitive to how that carbon, how long that stays in the air and collect heat, more so than anything to do with the current rates of emissions. So trying to limit temperature rise by a certain date, by limiting new emissions, without addressing the need to remove the existing carbon is totally meaningless. Because any projected target you're supposedly going to hit, 1.5 degrees by end of the century, 2 degrees by end of the century, the next year you're just going to blow right by it because you're still adding heat to the system. If this is going to be done fast, we can neither wait 30 years to overhaul existing infrastructure that we're already putting to good use or develop new technologies. It's totally unrealistic to throw away tens of trillions of dollars of cars and factories that are calibrated to only run on hydrocarbons, not to mention nearly every chemical process we have, including the production of materials for wind turbines and solar panels, that don't have an alternative to hydrocarbons. We should be using existing infrastructure to our advantage. So let's recap. In order to limit environmental damage and human suffering from climate change, we can't mess with the rain, we can't limit consumption, and we can't wait. This sounds a lot harder than even before, but we actually haven't reached the null set. No, in fact, we have narrowed the options and made the path forward so much more clear. We can take the very things that require energy and result in the release of carbon dioxide and force them, by definition, to capture and sequester carbon dioxide. In other words, we need to make fuel and products with hydrocarbons just as we do today, but with hydrogen and carbon from the air instead of from the ground. In this scenario, nothing downstream needs to change, and energy consumption all of a sudden has the exact opposite effect on climate. But to enable this, you need an extremely abundant and scalable energy source that's carbon-free. You guys see where I'm going here? Here's the best part, though. If any set of companies or countries starts to make hydrocarbons cheaper from the air than from the ground, existing infrastructure would deploy their product instantly, globally, without any international consensus, without any new taxes, without any change to individual behavior, and capture a $6 trillion per year market along the way. Let me make this crystal clear. If you use carbon from the air instead of from the ground, the more that people consume, the more prosperity we enable, the faster we will solve climate change. This is a complete alignment of individual behavior, market forces, environmental health, and human prosperity. If you want to actually solve climate change, you just need to make carbon-negative fuels cheaper than carbon-positive fuels. In the rest of this talk, I'll argue that not only is this possible, it can be done in a matter of just a few years if we use nuclear energy. Okay, so let's apply the same methodology that we used for climate change. Define a problem, properly constrain it, solve for X. Entropically speaking, it's going to take a lot more energy to make this fuel than you'd ever get from it. Probably 3 times as much. So that's the problem now to solve. Produce synthetic, carbon-negative fuels 3 times cheaper than fossil-based carbon-positive fuels. What are the constraints in this problem? Well, first, it can't just work in a lab. Your cost assumptions need to scale to global levels of consumption. So let's account for that constraint by stipulating that the cost of your material inputs to produce such an energy should always be decreasing with scale. This rule will also help us accelerate deployment. Second, in order to fully account for the life cycle of this system, if the energy source you use to produce synthetic fuels is intermittent, you must multiply both the capital cost and the carbon footprint by the inverse of the capacity factor. That makes sense, right? If you can only run a factory half the time, it takes twice as long to pay back. Well, the same applies for the carbon footprint too. Furthermore, you also have to account for the carbon and the costs of any storage technology that tries to even out the production curve. Now, I'll take any energy system that can totally account for the carbon footprint of its entire supply chain while beating fossil fuels on price to produce heat by a factor of 3. But considering those constraints, I have never seen an estimate by even the strongest of advocates for renewables that even comes close. So what technology do we already have that can stay within all these bounds? Only one. Nuclear energy. Nuclear operates at full capacity 24/7. I'm sure I don't have to tell you guys that. And it can scale to the global levels of consumption. This is because the only material input that is inherently tied to energy output is uranium, a fuel that is virtually infinite in supply. But we're going after cost here. And everyone knows that recent nuclear plants have proven too expensive. But the costs that we've seen are not tied to the energy source itself. Nuclear, in fact, consumes 1,000 times less material than solar or wind and is 3 million times more efficient than fossil fuel. It starts off 3 million times more efficient than an otherwise identical coal plant, and all someone has to do is figure out how to make it just 3 times cheaper. Now you see why I'm optimistic? On a first principles basis, nuclear checks all of the boxes. If you want to solve climate change without any international consensus, without any taxes, without any change to individual behavior, you just have to start by making nuclear energy as cheap as it already was in the 1970s and design it in a way where it gets to ride the manufacturing experience curve to ever lower costs. If you can get it that far, market forces alone will drive nuclear energy to very quickly become 3 times as cheap as it was in the 1970s. Just like every other thing that was manufactured in the 1970s. Okay, so let's get back to problem solving. In order to solve climate change, we need carbon negative fuels. In order to solve for carbon negative fuels, we need really cheap nuclear. So how do we solve for really cheap nuclear? Since founding the Energy Impact Center nearly 18 months ago, we have met with over 1,200 experts across technology, policy, regulations, international markets, economics, and more. We've produced 144 podcasts, as I'm sure you guys know now, and nearly 1,000 YouTube videos, all getting to this very question. How do we make nuclear energy cheaper? Now, obviously, this is best explained with spreadsheets and CAD models and cannot be boiled down to a few quips in an hour lecture. But following the thread of this talk, after we have a problem statement, we need a few constraints mapped out. Constraint number 1. Construction time should take less than 2 years. The recent builds have shown that up to 50% of the cost of electricity is driven by the cost of capital, namely the interest on your loan accrued during that construction period. Constraint number 2, cap construction labor. Now, they've got this rule of thumb in the industry about mega construction projects. The minute that the total labor force on your site hits 3,000 people, you can expect the costs and the timeline to build that project to double. Constraint number 3, make it manufacturable. Remember, not only does it need to be cheaper to start off with, but we need costs to predictably drop with scale. Okay, those seem pretty obvious, nothing controversial there, so why has this never happened? I have some guesses that we can probably talk about in the Q&A, but nevertheless, there are fewer than 10 companies that have ever brought a nuclear product to market, and none have designed a system to comply within those boundaries that I just specified. Notice that there are some commonly assumed constraints that I've left out. You don't have to build in the US first, or ever. Remember, carbon negative fuels can be shipped from anywhere. You don't have to reinvent the wheel. If the 99 reactors in the US are good enough to run today and to produce the cheapest continuous energy out there, that might not be a bad place to start. You also don't have to be a nuclear company to sell a nuclear product. Just like you don't need to be an architect to sell a skyscraper. This industry suffers from lacking the concept of developers. If you can round up a couple $1 billion and are a great project manager, you can license all the nuclear stuff from Westinghouse, GE, or any one of 50 startups out there. There are thousands of companies, hell, thousands of individuals who can get access to enough capital to start developing nuclear plants. God bless all the nuclear startups out there, but there is a lot of room for innovation in this space that has nothing to do with the reactor core. I argue that cheap nuclear is fundamentally a construction management challenge. So, let's do a final recap. To stop climate change, remove 1,000 gigatons of carbon from the air. To remove carbon from the air, produce carbon negative fuels cheaper than carbon positive fuels. To produce cheap carbon negative fuels, produce really cheap nuclear. Now you have the problem well defined. You have your constraints. Go solve for X. Thank you. I would be happy to fill the rest of the time with Q&A. I'm sure you guys are pretty curious either about episodes you've listened to or the content I went over today. Throw them at me. I've got fun shit up front.
All right, so I have two. Would you do this as a TED Talk?
Yeah, well, hopefully soon, yeah.
Okay, and the other one is, so I understand that the nuclear energy would produce the energy necessary to create a carbon negative fuel. How exactly would that work to make a carbon negative fuel?
Yeah, so, I mean, you guys know what a hydrocarbon looks like on a molecular basis, right? You got some C's, you got some H's, right? And like methane is really simple. It's pretty much just that. What you do is first you need to isolate your C's from carbon dioxide. So you need some sort of global scale direct air capture, or it would be even easier if you hooked it directly up to the carbon sources themselves. So first isolate the carbon dioxide and rip off the C. You can do that with enough temperature and pressure, you can pull apart any molecule essentially. But there are some neat processes that have existed for 100 years at this point that are even easier than just jamming a ton of heat and pressure into it. A little more complicated in some ways in terms of the material inputs you'll need, but they reduce the total energy input requirement. You can do the same with water, high temperature electrolysis. You guys have probably all heard about electrolysis too. So now you got your C's and H's, and now you can actually use these as the building blocks of synthetic fuels. There's nothing about that we haven't done for 100 years. It's just, why would we? Because it is way, way cheaper to pull it from the ground than to build it yourself with a ton of other energy from another source. But that's what nuclear can change, right?
So what would we do when they recreated the methane or whatever other molecules from the carbon dioxide? Would they just pump that back into the ground?
Well, no, what you want to do, and this is what makes this all work economically, is that you would actually sell it and people would reburn it, right? And so you have this continuous cycle of you be making the synthetic hydrocarbons, selling it into the market. That's what would allow for you to build all this infrastructure, and that would keep going in a net neutral way. But since you're pulling the carbon from the air, you can also start making all the products that require carbon. That's what makes it carbon negative. So the combination of making fuels and products makes your entire system net negative. And the more that you use, the more energy you use, the more stuff you suck from the air, the faster you're going negative. So that's the theory behind this. Please.
Well, this whole process sounds like it's going to have a massive economic barrier to entry. So how are you going to surpass this? It's going to be like government subsidized projects to get the ball rolling, or?
I hope not. But actually, I don't think there should be any government involvement in this. Period, hands down, end of story. If you can I'd rather just the government kind of relax the things that are constraining nuclear right now than impose taxes or subsidies of any sort. The barrier to entry isn't as high as you think. The minute that you can make new nuclear, right? Nuclear that I argue doesn't actually have to be any different than nuclear we've already created, but it's just has better construction management, and so it is much, much cheaper, the end product, the end electricity. You can start selling that into the market today, right? And so wherever there is a new power project going up, if you can build a nuclear plant, if it's a small one for 100 million, and someone was otherwise going to buy 100 million or 500 million, whatever scale you want, coal plant, natural gas plant, wherever they were going to put it, start selling there. Now you got the ball rolling, right? So first you're starting to sell, let's say it may be $50 a megawatt hour. You're competitive on the market today. And your entire capital barrier to entry was maybe only $100 million, $200 million, $1 billion, right? Well, now you're profitable. Invest in your next plant, your next plant, your next plant. As you build more and more of the same thing, the costs drop and new markets open up. Now, pretty soon your costs are so low that it is cheaper and easier for you to make those synthetic fuels and ship them than for other people to do the crazy stuff that they do today. digging, oil wells in the middle of the ocean. I mean, like that has a huge barrier to entry. So it actually will not be that hard to beat fossil-based hydrocarbons. We already know what the price of fossil-based hydrocarbons are today.
Will the reduction in price of nuclear of the energy also reduce the price of the carbon positive fuels? Because then you're also using energy to like dig up those fuels, or is that just mostly tied to the scarcity of fuel?
Yeah, if energy was a very large component for, let's say, pumping out fossil fuels, you're right, you could have negative effects like that. But that's not, I don't think that would drive a huge cost reduction. Actually, and this is what's so amazing about nuclear. It's like when you first learn about energy density, right? It's just amazing. Like, most of the cost of coal is literally moving the coal on train cars, around any given country, or on a boat. And they ship coal from Philippines all across Southeast Asia, Indonesia. And so the very fact that the thing that you have to move is 3 million times energy density is amazing, right? You don't have that with nuclear, but that is a cost that will always be inherent to fossil fuels, moving that much mass around.
So if you do achieve like cheaper nuclear, what is the incentive for a company to use that power to get the hydrocarbons out of the air rather than just using the cheap nuclear?
Right, so we hope that in certain situations, you'll be able to immediately deploy just the cheap nuclear, right? So that will knock out all sorts of carbon emissions immediately, right? And it's going to be easier to compete in that way. But then there are always going to be places that it's easier to just keep shipping hydrocarbons or many process units. Remember those factories I talked about and the cars I talked about, the tens of trillions of dollars in infrastructure? Those need hydrocarbons and those aren't going anywhere. So if you can beat out fossil-based hydrocarbons on price using a nuclear power plant hooked up to direct air capture, producing synthetic fuels, boom, you're in business.
So you mentioned that building agreement video, you're talking about how the bunch of startups work with unicorns. And I watched the podcast that you did with Jared General of ITER. What's your opinion then on fusion stuff? Where you don't bring all this money, time, and really people who have the ability to design better, more efficient things like this hydrocarbon from the air stuff. They're putting all this time and effort into making fusion power instead. What's your opinion on that whole sector?
Yeah. Well, fusion violates one of the constraints that we need to already have the technology available. So I don't think it's an option. We don't need to get into it now, but I also think there are a lot of things that people aren't considering. Remember how I started off the talk about, if you get everything you want, does it actually achieve the outcome you desire? Fusion should be asking the same question. If you could actually solve all the physics and materials challenges, is your fusion actually going to be cheaper than fission? I don't know. When you look at what drives the cost in a power plant, right, its complexity and its size, and almost by definition, a fusion reactor is going to be more complex and less power dense because, man, it does not get better than just running water over hot metal, right? That is simple and power dense probably as power dense as a thermal power cycle can actually handle. So in terms of this type of system, I think fission is already optimized more than fusion will ever be, even if you can work out all the materials and physics challenges. Now, you were asking what to do about all the people who are working there. I mean, yeah, a lot of brilliant minds. I mean, I like the ITER project. I like what it stands for. I like that it means that a ton of countries are getting together on scientific challenges, and the great minds are inventing advances in science instead of advances in weapons. I love what ITER stands for. And I think it's a better use of the brilliant minds than people working on Snapchat, too. So, we got plenty of talent in the nuclear space, I feel. I mean, obviously, we want more to keep coming. But I think this has a lot more to do with construction management than it does with nuclear engineering. Yeah.
So, another question. A lot of the issue with nuclear, you mentioned, has construction and the cost rise. But is there also a huge barrier for where people are more or less irrationally afraid of the radioactive waste, spent fuel, the potential for meltdown, all these things that people hear about from Chernobyl, from Mount Island, Fukushima, things that are very isolated, small cases compared to the untold number of tables from coal and
Yeah.
oil. So how are you gonna bridge that here?
Yeah.
How are you gonna get
That's
through that?
That's a great question. I'm glad you brought that up. It's something I have to think a lot about because you're right. Some people are very, I would consider, irrationally opposed to nuclear. But even in the US, I don't think it's a majority. I mean, as of 2008, there were going to be 30 new plants being built, and the communities all wanted them there, right? And it's just an economic crisis that ended that, not public opinion. Across the world, there are 30 countries that are trying to build new nuclear. They want it so bad that some of these countries are willing to pay double what they would pay for a coal plant just to get it. That's how much they want it there. But once again, it's economics that's really limiting its global deployment. So yeah, you're right. I think some people do have a bad public opinion, but it is not necessary to win over everybody in every place to realize this vision of building about 10,000 gigawatts of nuclear somewhere, shipping synthetic carbon negative fuels around the world.
So do you think that once, say we get some more kickstart going with manufacturing, do you think that'll help change what we have
Yeah.
that are working well?
Definitely.
So it's like, oh, there's no issues, and then you start seeing more and more, and still no issues, and just help the whole process along.
Yeah. Yes. I mean, I think that most people like to think that they're very rational about every decision they make, but it's really a lot of rationalization, right? So you're part of a tribe, and then your tribe has a certain opinion towards something, you find a way to like it, you find a way to rationalize it. I think when it is, and that's why you see like a lot of people are won over by arguments around clean coal, natural gas, right? All it took was one word of branding and it being a huge economic boom for people to rationalize why they love it. I think the exact same thing would happen with nuclear. But I don't think it needs to happen. I think, once again, a few countries, a few companies somewhere could solve the entire climate change problem themselves and become the richest companies on planet Earth in doing so.
In terms of the fission and fusion things, so you said that fission is not doesn't have the technology yet to be like efficient enough, and you said that if it does, it'll be cheap enough. But nuclear was when it first started out, it was obviously not like they didn't have the technology to do that, and it wasn't cheap enough. And people I think realize that things take time to become cheaper. And so what do you think fundamentally separates fission and fusion? What makes fission less efficient?
Yeah. Right, so let's just look at the core itself, where you generate the power, right? The amount of power that you can produce from a physical plant, from all of the investment that you put into it. We're going to assume both the fuel costs are negligible in either case, right? So we're talking about this type of power system where most of the cost is driven by the capital that you use to what they call capex, right, to build the structure itself. So on a first principles basis, we can look at what a fusion plant or a fission plant might be under any circumstance without even considering the nitty-gritty of, how you maintain your plasma or anything like that, okay? And you can look at the economics from that way too. You can say, well, how much stuff went into building this facility? The concrete, the steel, how long did it take? What was the interest that accrued, right? So you can come up with about how much it will cost, regardless of the technology inside, based on how big it is. And then you can scale how big it is and how much material will have to be based on the fundamentals of that technology, right? And so imagine any fusion system that you want, and then you give me the amount of coolant that moves past that hot thing, right? How it gets to the turbine, what turbine you're going to use, that's all probably going to be the same. And then you got to tell me how much does that thing cost to maintain and to build and to protect and to secure that is creating that heat. And we can do those calculations even without knowing exactly how the physics of the fusion work. And I argue that there is nothing simpler than dunking a bunch of metal rods inside of a bucket of hot water in terms of simplicity and power density and the amount of structure that's required from that in order to generate the electricity that you can assume that you'll get out of it. So I think on a first principles basis, we can rule out, listen, I like fusion. I like the idea and concept. I like scientific advancements. I think it will I think it could satisfy all the constraints that I set up, except for that it has to already exist. But I don't think it'll ever be better than fission.
So you mentioned putting like the carbon negative plants and smaller nuclear plants in different places. How would that affect like the renewables that are already in place and that would have to get replaced over time?
Yeah, I mean, renewables occupy such a tiny percentage of world energy consumption. It's around here. It just doesn't matter.
Would they like eventually get phased out and they would be useless? Or
It almost doesn't matter. I mean, it's like the infrastructure that you have set up. It's already paid. If it's already paid off, people use them. If the OPEX cost, right, operating it, maintaining it, if that exceeds what your electricity price is for an alternate source, they'll just shut them down. But it's so small. It's like when people talk about the advancements of renewables, or like progress that we're making against climate change, like it is a joke, right? It is an absolute joke. You are not. So I mean, you guys know the derivative of velocity acceleration. Who knows the derivative of acceleration? Jerk. Who knows the derivative of jerk? Snap, crackle, pop. Okay, you guys know this. It's awesome. Okay, right? So it's like all of these advancements that people are like cheering that, like, yeah, we're slowing down climate change. No. You still a positive jerk. You have maybe leveled off snap, right? And you might have a negative crackle. Any of these, new solar panels that you might add. The progress we have made is an absolute joke.
So while we talked about the hydrocarbon situation, kind of leads into the rest of the more or less whole plan for how to use carbon. But it kind of starts at one point, which is making it easier and cheaper to take hydrocarbons from the air down the ground. How big is this gap? How much harder is it? What's efficient right now?
Yeah.
Like how much do you close this gap before we start seeing this out?
Yeah, so I in addition to the work that we do looking into cost strategies for nuclear, we also meet with other people across other technologies and climate change at large. And what it seems, the estimates that I've heard getting is producing carbon negative synthetic fuels would require about 3 times as much energy as you get out of it, right? So that's your target to hit. If you can make synthetic fuels 3 times cheaper than carbon fuels, they can then compete with each other fairly, essentially. And that means, or if you can make energy 3 times cheaper to make your carbon negative fuels, they can compete fairly. So what's the gap? So let's say that your coal plant is operating at $40 a megawatt hour right now. So that's a good number across the world. The target would probably be around, $10 or $15 a megawatt hour of another source of carbon-free electricity, right? And what are we at with nuclear? Well, the ones they just built were like $100 a megawatt hour. That is crazy. But the ones that they built in the 70s are operating right now fully paid off and operating at $30 a megawatt hour. So they're all ones that we already built in the 70s are cheaper than coal, right? So that's what I'm saying. If we just started there, I mean, literally, if you grab the design dusted it off of Westinghouse's shelves and built, any one of the 100 reactors that they built in the 70s, you'd already have a 3x cost advantage over what they're building today, right? So that is a damn good start. And then you need all the brilliant minds to come in and say, how do we make this manufacturable? How do we make this scalable? As every part that we make into this, we make in a factory setting, so on and so forth. And that's how costs decrease.
So you talk about like the simplicity of light water reactors, but do you think that advanced reactors such as sodium fast reactors and other fast reactors that can use up long fission products when they run are part of the solution as well? Or do you think it's better to stick with the simple design of a light water reactor?
Ooh, good question. I get this a lot, right? Because people love new technologies. I think on a first principles basis, these advanced technologies actually will be the future. Because, there's certain things, and you could burn up more of the fuel, let's say, some of these concepts, without having to actually do anything to it. You run it at a higher power density, perhaps, right? But to get started, you gotta think about what drives costs. And a new technology, new materials, boy, I mean, you've got someone mentioned, well, what is the capital hurdle that we gotta get over to get started? If you use existing technologies, it's not that high. If you're using new materials that we don't know how to behave, that require an entirely new supply chain, I do think that's the future. That's almost what I would imagine would come out of the R&D budget of a giant nuclear company that has already sold trillions of dollars of light water reactors and can really invest the billions and billions and billions of dollars over many, many years to work out all the tiny little issues that we might not know about yet with these advanced designs. Now, other people tout these advanced designs for other reasons. Some people like passive safety, so on and so forth. To me, it's all about cost, right? What helps us get the cheapest, fastest?
So obviously, if you scale up nuclear energy like that, you're going to have a larger production of spent nuclear fuel, and a lot of negative public opinion the fact that we have no idea how to deal with the nuclear fuel, either repurposing it or storing it somehow to address that. That's that negative public opinion.
Yeah. Negative public opinion. Avoid it, right? I mean, you build places where we don't have negative public opinion. You can build them all there. There are only a few places that are really kind of antsy about the nuclear waste issue, right? US, Germany, Japan, Sweden, a few of these places, right? You don't have to ever build there, fine. Just buy synthetic. Those countries can you don't have to ever build another nuclear plant ever again. That's fine. Just buy synthetic fuel from the countries that want to sell it to you. Don't have these public opinion hangups, and I guarantee you, those public opinion hangups will go away real fast when economics come into play. And we all know, like, the waste actually doesn't pose a hazard itself, so it really is just a public opinion question. I say just avoid it.
So would you be buying the synthetic fuel from the other countries, or would you be buying their energy and making the synthetic fuel where you're at?
Yeah, I think that all just comes down to an economic analysis of shipping electrons versus shipping fuel. And so, this could happen in any number of scenarios. I think first it would probably depend on which country was to kind of really kick this into gear. If it was a country that had access to a larger electric grid, you'd probably start selling electrons, and all sorts of people might kind of bid into that market to then create their own carbon negative fuels. But it really depends on where it all starts, yeah. Is there a question from there?
Is there any legislation here that's like driving construction?
Oh, yeah.
He's asking about red tape.
Oh yeah, I know. Like, we can't build, I lived in San Francisco for 6 years, and I watched the Bay Bridge get finished being built. It was like 4 years overdue, maybe 5 years overdue. It's supposed to be $1 billion around, $6 billion. And when you look at this thing, it's like, how did they get it so wrong? It is literally just steel and concrete attached to each other. Like, it's a bridge, and yet their estimates, like the estimates they sold it to the government for, or the municipality, were like that far off, right? So there's a lot, but that doesn't happen in China, right? So it's like there's a lot of issues with construction economics itself that are driven by Western world regulations, Western world attitudes. I'm not even saying just like environmental permits or anything like that. That's not what I'm talking about. There's the way that the construction management companies fundamentally operate in the U.S., it's a bit shady, right? They're trying to milk every project for all it's worth. They're incentivized to have as many what they call change orders as possible, because that's what drives up their bottom line. And so your incentives are not perfectly aligned between your construction companies and whoever your project developers are. And that is like common throughout at least the US and probably the Western world. And that's a real problem if you want to do big projects that are fewer in quantity. If the smaller projects that are smaller in quantity, or that are larger in quantity, then you've got that other economic incentive putting pressure back on a system where people are like trying to do a good job so they can be the cheapest bidder on the next one.
Okay, so
Was that the bell?
that's about
Thank you guys so much for coming to listen to me. Let's do it.